Hey guys, hope you're doing well today. Got one last video on this section before you take a quiz on it. And if you don't do too well on the quiz, then, well, too bad, so sad. You haven't paid enough attention in the videos, I guess. It looks like you're doing fine on the homework. You know, most of you guys got all of them right, but that doesn't really mean much because you could keep doing the problems over and over again. But anyhow, so you're going to have to do well on the quiz today, and I hope this last video helps you do better on it. Um, okay, so I'm going to go over the ones that some people had issues with on the homework. Just remember, for your sake and purposes, two key things here. I is equal to the square root of -1, and I squared is equal to -1. Okay, those two key things are all throughout this lesson. Okay, now somebody missed this one. I don't know, were they just too lazy to go back and retry it? I'm not sure, but if you're multiplying two complex numbers, you want to do FOIL, so let's do it. So 7 times 5 is 35. That's the F part, the first terms of the binomial. Okay, you have to pick up some pencil and paper and write this down. If you try to do this mentally, shame on you. Okay, 7 times I is 7i. Okay, that is the outside. The inside is -20i. Okay, and the last terms of each of the binomials is -4i times I. So that is -4i squared. And now remember, we're going to use, we need to combine like terms. And we're also going to use the fact that I squared is equal to -1 to rewrite this I squared as -1. So it's going to be -4 times a -1, because I squared is -1. So this really just becomes a +4 here. Okay, these two middle terms we could combine. 7i minus 20i is -13i. Okay, so we have 35 minus 13i plus 4, then combine 35 and 4, and you'll get 39 minus 13i. Okay, hopefully that helps you with that one. Here's just a random problem that I threw in here for review purposes. You guys seem to have gotten these ones right. Here you want to solve for x, okay? But first you want to get x squared by itself. So you could also try factoring and solve this one by factoring, but we're using the square root method here in this lesson. So we're going to move the 81 over to the other side by adding it. So we're going to add 81 to both sides. We would have 3x squared equals 81. Next, you want to get rid of the 3, so you're going to divide both sides by 3. Alright, so we will have x squared equals 81 divided by 3 is 27. Alright, now if this was -27, you'd pull out an I. I forgot to make this one negative, so my bad on that. But now remember, with this method, you take the square roots of both sides, and when you do that, you get a positive and negative answer. Okay, so you have a positive and negative answer, and you need to simplify the square root of 27. Okay, so you have to think about what perfect squares go into 27. So 9 times 3. 9 is the perfect square. You always want to split it so that one of these twos is a perfect square. One of these two factors is a perfect square. So square root of 9 becomes 3. So you remove that from the square root. Square root of 3 is still square root of 3. And so there's your two answers. Alright, so anytime you're solving an x squared equation, unless your answer is 0, you should have plus or minus two numbers. Alright. Another problem that someone had issues with was this one here. You want to divide it, it says. Really what they want you to do is get rid of the imaginary number in the denominator, okay, and then rewrite it in the form a plus bi. And so remember, to do that, you have to use something called the complex conjugate, okay? The conjugate will eliminate the I from the denominator here. So if you take this expression, and now on the top, you want to just imagine there's parentheses around the whole top and parentheses around the whole bottom. Now if we want to get rid of this I in the denominator, we need to multiply by the complex conjugate. Alright, And so what is that? Well, you keep the real part the same, but you change the sign on the imaginary part, and that will cause the imaginary part to get eliminated when you do multiplication or foiling, okay? All right, so you're going to multiply the top and bottom by the same thing, so you're essentially multiplying by 1 here. All right, so on the bottom, there is the shortcut when you are multiplying by the conjugate. It's a squared plus b squared. So here we would have 3 being a, so we have 3 squared, and we would have 4 or negative 4, whatever you prefer, doesn't really matter here, being b, okay? Because when you square a negative, it's the same thing as squaring a positive. That's why I said it doesn't matter, okay? So you get 16 out of that part either way. Now on the top, you have to FOIL. So we would have 15 for the first terms, outside, so there's the first, there's the outer, 5 times 4i is plus 20i. Inside would be negative 3i, and the last term would be negative I times 4i is negative 4i squared, okay? And then for speeding this along here, we would have 15. 20i minus 3i is minus, or actually positive 17i. Minus 4i squared, remember that's the negative 1 times negative 4, so this becomes plus 4. And on the bottom, we'd have 9 plus 16, so this becomes 25, okay? 3 squared's 9, 4 squared 16. That's how I got the 25. Okay, so now you just combine like terms. So this would be your next line here. 19 plus 17i all over 25. Now when you write this in imaginary form, a plus bi, you have to make sure to put both of them over the denominator. Okay, so you'd have 17 over 25, and you can put the I out in front there, okay, which really means that it's on top. Okay? Okay, and on to the last question, which is a shame that so many of you missed, because this was probably one of the easier ones. You just have to read and use your brain a little bit here, and maybe look at the example if you have some issues. So this is about actually how you could use imaginary numbers in a real-life application here. It's about resistance on electrical currents. That's what impedance is. Anyhow, so you're basically finding the sum of two impedances. Okay, they give you the one here and they give you the other one. What is the total impedance, or the sum of the two resistors? So in other words, you are simply adding, okay, 9 plus 5i plus the other resistor, 8 minus I. Okay, now these parentheses, since you're adding them, don't really mean much. Okay, so you could just disregard them and then just combine the like terms. 9 plus 8 is 17. 5i minus I is plus 4i. So what is the total impedance? 17 plus 4i, and that's it. Hope your quiz goes well for you, and we'll start something new on Thursday. Have a great day, guys. Bye-bye.